Hi, everybody. Welcome to this webinar on the evolution of stir shaken in Asterisk, given by me, Joshua Colp. As well on the line, we also have Mike White from the sales side. So if throughout this you have any salesy type questions, of which I am not a great person for those, then he'll be more than happy to answer those at the end when we do Q&A. As well throughout this, if you do have questions, submit them through GoToWebinar, and then I will circle back at the end and go through those and answer what I can. With that, let's get started. So, hi everybody. My name is Joshua Colp. I'm from Atlantic Canada, which is actually further east than the Eastern time zone. We are in the Atlantic time zone, which is an often forgotten time zone. I've been with the Asterisk Project for over 20 years at this point. So I've seen it go from a beginning of a project to big one, gaining testing stability. I've seen quite a lot of things. I started out submitting bug fixes, then moved on to features, eventually joined Digium as a software developer on Asterisk, and then rose up through the ranks, where I am now the project lead. As well in my spare time, I enjoy cycling, and I've also started running. And from a you might know me perspective, I'm also known as File in some places or J. Colp. So if you've seen those in the project, that's me. Hi. Um, and this webinar is about Asterisk and Stir Shaken, but before we really get to Asterisk, I'd like to ask the question, what is Stir Shaken? Because it can often be misunderstood what it really is. So Stir Shaken, from a technical perspective, is about caller ID authentication. And it's made up of different technical standards from various places that define how to authenticate the use of a caller ID number. Note, this doesn't include name. Name is not covered under Stir Shaken. Underneath, this uses certificates, as does so many things these days, including the websites we visit using HTTPS. And really, it's meant to stop, mitigate, or reduce caller ID spoofing. And when I just mentioned these things, I was speaking from a technical perspective. There is also another aspect that I won't get into, which is a policy perspective, which differs based on countries and is really built around the policies of actually using the technical technology to accomplish these things. So how does Stir Shaken work? A certificate must be issued and used. This can include numbers that can be authenticated, i.e. numbers that you are able to send as your caller ID. As well, some entities can get delegated certificates. These are cases for call centers that are making calls on behalf of other parties. And when you send a call, there is per call information which is produced and signed using the certificate that authenticates your use of the caller ID. And all of this is included with the actual call itself. This signed information includes the number dialed, the caller ID number, a time, and other details. And the time and number dialed and all the details really are there to ensure that this signed information can't be reused for other purposes at a later date. You really need to generate it each time you send a call and not reuse it. For SIP, this gets placed into the identity header. So if you see calls coming in that have an identity header, that is Stir Shaken. For receiving a call, the incoming call, like I mentioned, contains a signature in the identity header, as well as all of the details. It also includes a URL for the public certificate for the sender. Certificate is made out of a private side and a public side. Public side is willy-nilly. Anyone can download that and use it to verify things. Something that came up as a result of Stir Shaken is that the public certificate has to be accessible to the receiver, and so you have to essentially put it on the public internet. The consequence of that is the act of getting that public certificate actually interrupts your incoming call flow handling, meaning it can slow it down. If that remote server has issues, then it can add latency on or block for a while. So one of the recommendations if you are hosting your own public certificates is use a CDN so that the public certificate is as close to the receiver as possible, but also as a receiver, cache when you can. And this is something I'll talk about a little bit later in relation to Asterisk. So the public certificate is downloaded, verified against the certificate authorities, and then the signature is verified against the public certificate as well. Contents are verified against the call, so caller ID number used, that it hasn't expired, that the dialed number is correct, and at that point, verification is now done. Verification also includes levels, and this is called an attestation. So there's 3, A, B, and C. A means that the caller ID number is registered with the caller. So that would mean, hey, this phone number is on their account, they can use it. B is the caller ID number is not registered with the caller, but the caller is known, meaning that there's a relationship there. So that could be, they may have signed legal paperwork saying, yes, this is who I am, and that's been verified. And then C is a last resort, which is only the gateway the call came from is known. We don't know the caller or the caller ID number. So very little is known about them, just that, hey, this provider sent us a call, we know the provider. So do you actually need to worry about all of this? It's a good question to ask. Ultimately, like many things, depends on what you do and who you connect to. If you are a normal retail user, then probably not. Your provider will handle it. If you are others, then you probably do, and this is something that you need to be aware of from a policy and perhaps technical perspective. As always, disclaimer, this is not legal advice. No, this is not legal advice. Please consult current regulations and legal aspects for your location. This stuff is complicated and it's changing all the time. What isn't stir shaken? It's not for stopping spam calls as much as some of us may want to think that or hope that. Stir shaken only authenticates caller ID number. It does not inherently convey intent. A spammer can still technically send you a call with a valid caller ID number that they're allowed to, signed with an A-level attestation, and that would be a gold standard call, but it can still be a spam call. However, you can deduce to a degree that a number with a lower attestation may be spam. And that's just deducing. You don't know for sure. There are services that are explicitly made for spam call mitigation, and they do use stir shaken as a factor. However, they do also incorporate other factors on top of this to provide their services. One of the nice things about stir shaken, however, is that it does provide traceability for calls, so complaints can be filed against a provider for terminating spam calls. With all that being said, stir shaken alone does not stop spam calls immediately. And now, Asterisk. Yay, Asterisk. So in the beginning, many years ago, stir shaken was still being talked about, technically spec'd out, the finer points of it being figured out, as often comes into, as often occurs when you actually try to implement things. Asterisk itself was one of the first implementations for stir shaken, to the degree that we didn't really have anyone to test against at that point. And like I said, standards were still in flux and the quirks were still being identified. This was truly the early days, and our implementation showed over time, as it continued to evolve, the standard that is, we failed to work with others. Some examples were the certificate type for stir shaken was changed. The way the signature was presented was also changed. And overall, the finer points of how all of this works just changed, and we became incompatible with everyone else, unfortunately. And this really came to a head at an event called OpenSIPIT. Um, and I'll talk about OpenSIPIT a little bit and go back to SIPIT. SIPIT was, and still occasionally occurs, but rarely, it was an event where different companies, open source projects came together, only engineering people, and were able to test against each other to figure out where our own SIP implementation was broken, where we weren't RFC compliant and someone else was, or vice versa. And it was just essentially an event to get together and make sure everyone could talk to each other, so that in the end, users and deployers didn't run into problems. And this kind of faded away as the problems with SIP were really identified, as it was over time. And so there's not as much unknowns these days. So OpenSIPIT was a community-driven event, and it also still occurs occasionally, that came about to fill the place of SIPIT. And during one of these events, one of the things that was tested were the various stir shaken implementations. And so we were able to, through that, identify where exactly we needed to make changes, where we were falling down, where those issues actually were. As a result of that, we came up with a plan for improving our stir shaken implementation. We wanted to leverage the third-party libraries that existed or came about since the time where we actually implemented our original implementation. We wanted to update our configuration to conform to the modern way of using stir shaken and what people need, as well as just updating code to conform to current standards and requirements. So since the beginning, when the initial implementation was done, a lot of the standards and specs and policy stuff became more concrete. And so targeting that is what we needed to do. What did we do? Let's break it down. Stir shaken support in Asterisk, like many things, is modular. This is the way it was originally implemented and designed, and we continued on. So the res underscore stir underscore shaken module provides common stir shaken logic, configuration, and handling. We've done it this way just in case we need to add stir shaken support to anything else. And then we have an interface module between PJSIP and res stir shaken for the SIP side of things. And that's res underscore PJSIP underscore stir underscore shaken. You might note ChanSIP, not on this list. ChanSIP does not have stir shaken support. And as a reminder, when I am always doing presentations, I remind people that as of Asterisk 21, ChanSIP has been removed from the Asterisk source code. So if you are still a ChanSIP user, then please look at moving towards Chan PJSIP instead, because you are fast approaching a time where ChanSIP will no longer be an asterisk. So JWTs, JSON Web Tokens, we're all likely using them every day, and this is what Stir Shaken uses in the identity header. So it uses it to convey the information I talked about previously. So called number, caller ID number, that kind of stuff, as well as a signature from the certificate. Our initial implementation didn't leverage a third-party library. We wrote our own JWT implementation. And this was really one of the fundamental incompatibilities that we had with other stir shaken implementations. So rather than just continue to maintain our own implementation, we opted to use a third-party library called libjwt instead. However, this did introduce a new dependency for stir shaken, So libjwt is now a dependency if you want to use stir shaken. It is not a hard dependency for Asterisk, meaning that you can still build Asterisk without libjwt. You just won't have stir shaken support. Curl. So curl is both a command line application for downloading files, doing HTTP requests. It is also a library that Asterisk uses for various things, including the curl dial plan function. So in stir shaken, we needed a method to retrieve the public certificate in the identity header, and we used libcurl for doing so. Since we already had curl support in Asterisk, it just made sense. We also wrote a caching support so that we don't have to continually go and retrieve public certificates. If we receive calls from the same sources with the same public certificates, we'll just use the cache instead. And that's just to reduce the call setup time. This logic, however, pretty much remained unchanged. It was working previously, and it also accounted for a security aspect. So the public certificate, you're given an HTTPS address that you then go retrieve it from. One of the things to consider is that the HTTP address can have a host name that actually resolves to an internal IP address on your network. So it's kind of a way that an attacker could potentially do something on your network. And this actually came up as a reported security vulnerability against Asterisk a few years ago in our stir shaken support. And so we opted to add a configuration mechanism for stir shaken that allows you to limit the IP addresses that are accessible to prevent requests against internal resources from external actors. And this essentially works as an ACL that you might also use from the SIP perspective. So you can just ACL out your internal networks so that even if they attempt something, then it won't actually work. Those requests as well can't post data, they're just get. So they're just getting data. So it was still a somewhat rare security vulnerability, but we still patched it nonetheless and provided configurability for it. So let's talk about configuration of the res stir shaken module. So it's configured in the stir_shaken.conf configuration file. The sample configuration file is heavily documented. I highly suggest you go take a look if this is something you're going to be deploying and using. And this is really because stir shaken is complex. When George was working on this, just like with E911 support, he had to put together all of the specifications, policy, everything. And so the documentation reflects that as well as the configurability. So attestation object configures signing settings for outgoing calls. A verification object configures verification settings for incoming calls. A TN object configures a caller ID number, i.e. telephone number information. And then a profile object configures whether we are signing, verifying, or doing both. And this is what is really referenced by PJSIP endpoints. The attestation objects, it primarily configures the key and certificate information for signing, as well as the public URL for the public certificate that is placed in the identity header. And then there's a few other odds and ends in there as well. The verification object configures a path to the certificate authorities, as well as some caching configuration for HTTP requests. And that is, like I said before, when the public certificate is retrieved for incoming call, as well as some lifetime configurability and odds and ends. From a lifetime perspective, that refers to how long before we consider a identity header from the SIP side to be stale. So if the lifetime of a signature is 30 seconds and we actually get the signature after 60 seconds, we would consider that stale and not actually be able to verify that. TN object, fairly simple, configures telephone number to certificate mapping, includes private key and public certificate, as well as attestation level. And then the profile object. This is what configures behavior and is referenced by the only thing right now, PJSIP endpoints. Configures whether attestation and signing occurs, as well as allows overriding of attestation and verification object configuration options. From the PJSIP perspective, it's extremely minimal and simple. It's one line on an endpoint, which is just stir shaken profile. And that specifies, as you might expect, the stir shaken profile to use for an endpoint. And that's it for PJSIP. So putting it all together, if signing is configured, then an identity header with signature will be automatically added. If verification is configured, then the identity header will be examined, verified, and results made available in the dial plan. As well, I highly suggest, if you're looking at this stuff, to look at the full documentation on docs.asterisk.org, and you can find it by searching for stir shaken. It'll be the first result. As well, what good are verification results if you don't actually get to look at them and use them? So there's a stir shaken dial plan function, which can be used to query for verification status information. And really based on this information, a deployer or user of Asterisk can write dial plan logic to react accordingly. You might reject the call if a call with the lowest attestation of C is received. You might change the caller ID name that you're sending an endpoint to provide a little bit of additional stir shaken information. And this is done by some retail providers as well. They will add like a V at the front to indicate that it's verified. Or you can put this information into CDRs for later record looking, or emit it as a custom CEL event and then consume that through some other mechanism. As well, through the actual logic in the dial plan of looking at the verification results and wanting to do things, you might want to hang up the calls. And to this point, Asterisk has traditionally only allowed ISDN cause codes when you're hanging up a call. If you call hang up in the dial plan, an optional argument is an ISDN cause code. That mapping between ISDN cause codes and SIP responses is pretty lossy at times. And so through this stir shaken work, we decided to implement a PJSIP hang up dial plan application. And this allows you to hang up with a specific SIP response code instead. So you don't have to try to finagle ISDN cause codes. This is usable for not just stir shaken. You can use it for whatever you want. In the past, if there's been cases where you've wanted to send a specific SIP response code, but you were unable to, then PJSIP hangup is your answer. And all of this is available in Asterisk 18.22.0, 20.7.0, and 21.2.0. Oops. And I realize this is a quick webinar. And I will get to questions in a second. I just want to add a final statement of stir shaken's complex, as I said in the beginning. If you're deploying stir shaken, expect pain. You will have to keep on top of policy within your country, such as the US. And Asterisk these days, as of those versions, can now help you if you're in a position where you need it to. That doesn't mean that you have to do it in Asterisk. You can do it other places. You can opt for choosing an outside provider that can handle things for you. But I can happily say that as of these versions, the support does work, and I am aware of at least one deployment that is using the support or about to. So that's quite exciting to see. So I'll be pulling up questions. Hey, and there are 7. Before I get to that, if you want to follow me on Mastodon, I'm available there. As well, if you run into issues or anything, feel free to file issues if you believe there's a code level issue on the Asterisk GitHub. But from a user community perspective, we're also available at community.asterisk.org, not just for Stir Shaken, but for whatever you encounter in Asterisk or want some help with doing various things. And now, will a recording be made available? I would guess yes, and I will commit to that. The process, okay, so there's a question about process to get certificates. This goes into policy level thing, which I don't really want to get into. You'll need to, whichever country you're in, look at the authority that is handling it for your country and then go from there. Also, I am from a call center. We make outgoing calls, but not the robo type. Do we have to implement Stir Shaken in our end? That depends upon your relationship with your provider. Maybe, maybe not. Welcome to the world of Stir Shaken, where sometimes the answer is maybe, maybe not. It depends. Does Stir Shaken affect the whole resources or can be set to specific one? Within Asterisk, if you are referring to a specific endpoint, then it would just affect only that endpoint. You don't need to enable Stir Shaken on your phones, for example. You would just have to enable it if it's applicable to your situation on the endpoint used to your upstream carrier. Cool. Does Sangoma have any plans to add Stir Shaken configurability to either the free PBX or PBExact products? Unfortunately, Lauren isn't here today. He's the product manager for free PBX as well as PBExact as well as Asterisk. So I'm not aware currently of any plans to. The number of people who are using free PBX or PBExact that this would be applicable to at this point, using those, I think is probably low. But if there becomes a case where it makes sense, then I'm sure he'd add it to the roadmap. Let me clean up these questions. Another question about what authority provides Stir Shaken certificates. That's a policy question, like I said. Thanks for the webinar. My question is, this is only related to EEUU. What about ISP from Latin America? This is dependent upon country-specific policy. So that is something I'm not aware of anything currently for Latin America, but that's not to say there isn't or isn't planned. And then Elvita confirmed that yes, a recording of this webinar of me rambling will be available in a few days on the Asterisk social media. Might be jumping on this a little bit early. Is there any support for showing the call as verified on a P3X or a P-series Sangoma phone? Not currently. The phones themselves have no direct support for any of the Stir Shaken stuff. or any headers that would indicate that. It's been talked about in the past. I just don't think it's something being worked on right now. My recommendation from a deployer perspective would be to manipulate the caller ID name and add a prefix to that to indicate that it's been verified. Question, if this is not fixing the spam/scam calls, what needs to be improved to fix this permanently? People always find a loophole to bypass or use the stir shaken. Um, that's an excellent question, and I don't know if I've thought of a good way to actually do that. In the US, the SMS side has taken a very hard stance on that whole stuff of campaign registration, monetary costs, and that kind of thing. Um, this is me going off into my philosophical kind of land. The trackability or traceability of stir shaken helps in that providers are now being more, um, they're actually facing consequences as a result of spam and scam calls. Um, so they are becoming more incentivized to not allow it on their network, which is a good thing and helps. Whether that will ultimately fix everything, I don't know. But it's a step in the right direction, which maybe it wouldn't have been required if customers and business associations were more vetted in the first place, but we'll see what happens. Is there support for RCD, rich call data, i.e. call branding? There's nothing inherently in Asterisk to support that. Um, there was rumblings on the IRC channel a few weeks ago, and um, no one could really state how it's supposed to work. I think one person said that it was just a custom SIP header in the invite that provided more information, but nothing currently. If a patch did come up that some specific support was required for it, and we'd certainly evaluate that. It's Pitsky. Hello, Pitsky. I missed some of the webinar. Not sure if this question was addressed. Would you know if there would be project like Let's Encrypt to issue certificates? I don't see anything like Let's Encrypt happening for Stir Shaken. They really want to, at least from a US perspective, they really want to hold things down a bit more. So that goes back to policy, policy, policy. That's a country policy thing. What level of attestation would forwarded caller ID fall under? It would probably fall under B because the upstream would know you as a customer and trust you as a customer. That would be my expectation. Forwarded caller ID is one of the things in Stir Shaken that wasn't thought about originally, even though people asked about it. No one, because it's a hard problem to actually solve. And so it's only recently, over the past while, that standards have come into place that try to address it. I haven't looked recently to see the state of those. Um, Essentially, it was how can we preserve the existing attestation and signature, but still say that we want this other caller ID to be presented. So there may be changes in the future to Asterisk to facilitate that, but nothing currently. How it works for the anonymous calls. What if the user using the VoIP to call the incoming number? So you can still, that depends upon your relationship with upstream. So you can still send a caller ID, but have the presentation withheld. You can also send it as a B-level attestation. So yeah, so we support that kind of stuff. Move. Hey, I think I'm through the list of stuff. Does anyone else have any other questions that they would like to ask? I will also accept non-stir shaken related questions. And if you have sales questions, then I'm sure Mike is still lurking on this call. Otherwise, as stated previously, the webinar has been recorded, will be made available in a few days. As for the questions for where this will be posted on, I know Twitter. The answer is, yep, Twitter. So you can check there. I also have a thread on community.asterisk.org for this webinar. And so once the recording is released, I'll probably do a follow-up post on there. So you can follow that post and receive notification that way as well. And with that, I think we are out of additional questions, and we can call this webinar over until my next one, whatever that is, whenever that is, and whatever that will be about. Have a great day, everyone.
You too, Josh. Thank you.